So the relation called Bayes' law is so important for statistical inference that it's very useful to give each of its pieces their own name so that we can talk about these things, sort of as a little language. And you've already probably been hearing me using those languages. At this point, I can't help it. And my goal for you is to get you to the point where you can't help it, too. Whenever you see one of those, you go, oh, posterior probability, prior probability, likelihood, etc. So the basic idea is we have a hidden variable. It's unconditional probability prior to taking into account any observations. We call that the prior probability of the hidden variable. After we take into account the observations, we refer to its new probability, conditional P of H given O, as the posterior probability. It just comes from the Latin words for before and after, prior and posterior. One other thing that is crucial as a term is sort of the converse conditional probability of the observation given the hidden variable. I will always refer to that as a likelihood or a likelihood model to distinguish it from the converse. So posterior likelihood. The term down in the denominator, I think it's useful to refer to this as an average likelihood because one way of thinking about it is it's basically this likelihood but averaged over all possible values of the hidden variable, properly weighted by the unconditional probability of that, of the possible states of that hidden variable. Okay? So basically, this is the average probability of a particular observation over all possibilities of a hidden variable. Okay? So that's the basic terminology that I'll use to talk about Bayes' law. Question? It is a summation, but it's a summation of this weighted by that. Right? We're weighting these terms by something that sums to 1. So that's like how you calculate an expectation value. Right? So you can think of it as basically this is the expectation value of that, where we're summing over all possible values of a hidden, unknown state. Other questions? Okay. So the great thing about Bayes' law is it's a recipe. You follow the steps or the ingredients in the recipe, and it gives you an answer. A wonderful, simplified way of solving inference problems by literally just asking yourself a series of questions. What is my hidden variable? What is my observed variable or variables? What is the model that I can use to connect those two things? In other words, to assume a particular state of my hidden variable, and from that to say, what would I expect to see from my observable, basically as a probability distribution. Then I need to come up with some kind of prior probability distribution for my hidden variable. I need to be explicit about what my set of possible hidden state values for my hidden variable. And then I just use Bayes' law to compute the posterior.